Hi there. In one of my video series, I tried to implement microkernel of operating system using a Rust language. And unfortunately, because of my lack of my experience and knowledge in this language, I had the difficulties with language itself and understanding the concepts of it, though I used some tutorials to guide me through. So I decided to start it over and learn Rust properly using some materials, and just to keep me accountable and have more fun of this process, I decided to record this and call this series Let's Learn Together. So I will go through a book. So I got myself the Rust language, Rust programming language, book that covers Rust language from 2018 edition, which is mainly used currently. And this was suggested by many of my my friends who programming on Rust on a daily basis. So basically, I will just read this book, use this as a notes for these videos, and show all this progress. And so let's get started. First of all, the book suggests, so I have the book on my left side and the coding on the right side. The book suggests that we install Rust, and I assume that you're able to do this by yourself, so it's kind of time consuming to explain for all different systems. I did it for Mac, just using a recommended installation way. Basically, it's just use curl to load some sneaky, sketchy shell script, and this shell script does all this magic. And in the end, I have Rust, so I make this a bit bigger, and I make the font also bigger. So I hope you can see this. Can I make it even bigger? Yes. So I have rustc, this version. Maybe I should have updated. I don't know. Maybe we can update it. rustc. Okay. A moment. Update. Unrecognized option view. How we can update this? Okay, we need to do this using Rust app. So we have this Rust app as well, this kind of a tool to install all these things, and we can just call this with this command, and this, I guess, will update to the current version. So I installed this like almost half a year ago, I think so. Hope this everything will work. So as you see, it's everything like alive. I'm not gonna edit much this video, and I probably will leave all these bloopers in, and I think it's totally fine. So you see that we're updating the version, and maybe I make the light a bit myself a bit later. Okay. Yeah. It's taking along. But I see it's updating everything. Like I see it's updating linters. I see it's updating a formatter. Compiler itself currently is going. It's downloading the compiler new version, and it's updating cargo. And we'll see what was there. So, okay, great. So now our Rust apps. I was going to this version. So it's from July, a month ago. Great. I think is, so I assume you installed this. If not, you just go to the rust-lang.org, you click on install, and it gives you a recommended way. If you have any problems, there's like 100 ways to install the Rust language for different platforms, different CPUs and architectures and so on. You can go through all these things by yourself and have fun with that. Other cool thing in the Rust, like it's similar to the Golang, that they provide you with a playground where you can just run some snippets, save them, share them. It's kind of fun to play with if you don't want to install this. Yeah, because they have this like learning thing. They have also so-called Rust book. It's actually the way to learn Rust, I guess, and all books are based on these knowledges, this Rust book, and I assume this Rust will be this Rust book will be up to date for any small changes in the language and so on. And this basically goes through all the topics that we will go. So if you don't want to buy this book, you can just use this one. Actually, I will use this as a reference for myself as well, because it's more like a documentation. So they give you some really good explanation on every single thing. I already used this. It's fun. Yeah, it's more like a documentation reference than a book, but with a better language. I really appreciate the modern languages that they provide us with this type of documentation. It's really good. Yeah, so let's get back to this. And this book says, okay, we write a hello world. So we create first. It says we create a main rs hello world. We can do it. We can call like make a directory like make directory hello world. I call this version 1 because the book also will have another way to do this. And we go to that and we make a file called like main.rs, stands for .rust type, and I would open this with Emacs. Yeah, so in this case it says, okay, just write a function called it says we will write a fun in Rust. Fn, they call it fun in Rust, just a cute thing. Main function doesn't have any attributes, and it's very similar to the other languages like C-like languages in terms of this function. To the Go, particularly in the Go, it would be like func, main, and all these things. And curly brackets basically is the body of the function. And it says we use println, exclamation sign, and here hello world. basically, yeah, and semicolon at the end. As this book says, it's everything fine and great. So I will just close this, and first of all, because it's compilable language, that book says we need to compile this, and we would compile this with rustc, so Rust compiler, and provide it with a file that we want to compile. Okay, provides this, but of course we always can do this verbose thing, I guess. It's already compiled. Because the cool thing, Rust compiler doesn't recompile if we didn't make any change in the source code, so it just saves you time. And if we do like ls, we would see there's main. This is basically a file that the compiler produced. Main.rs our source file, and main.rs tilde, it's a temporary file of Emacs. And we can run this main thing, executable, and yeah, it works. Let's remove this and try this verbose command. No, it doesn't produce anything. Weird. I actually expected that it would give us some information on how much time it took to compute this, but I guess it only works with cargo. Yeah, whatever. Okay, yeah. Basically, that's it. That's how the compilation works, and we're using the rustc. But just to note, rustc has like a lot of options to launch, to make optimized code, to compile this for different targets, and so on, like with different profiles. And all these like options, they have like on meaning, and you can. I'm not familiar with them. Maybe it makes sense to but let's say like B. Yeah, there's no much difference, I guess. Okay, yeah, well, so there's maybe I'll get to this as well later. I have no idea how to use all this. Anyway, I'm not going to use like a pure rustc. I will use cargo. So let's get back to the cargo. Cargo, it's a project builder and package manager of Rust, and basically majority of programmers use cargo instead of like pure rustc because it does so much for you and makes it way easier to manage whole project. I wouldn't say it's just a project, a build system, and just a build system and package manager. It does a lot. Like it's a lot of small neat things that makes your work like a bit easier, a bit funner. Just so those tasks that you repeatedly do on every new project, it just takes this from you away. And the cargo, if you install this, we're using Rust app, and it will be on the command cargo. Just a one tip: if you're using Z shell or online Z shell, you need to put this in your Z shell profile. This export like path to the cargo and Rust. Otherwise, it writes only to the standard bash. At least it was when I installed first time. But after updated, it works, I guess. Okay, so got cargo this thing, and we're interested in the one thing called cargo new. Obviously, it's produced like new project, and we call it like also hello world. And if we hit enter, it says by default it creates binary, but we can provide with some parm which makes not binary, but library. So some library that we can provide to other developers, which can be installed also by Cargo. Yeah, so it produced the new application package, and if we make ls, we see it's a hello world. I would go to the hello world, and just with ls we'll see it's produced as a cargo tunnel and a CRC file, a CRC folder, and I'll do like just ls for cargo. It says basically it produces it says a package. It has a name hello world, version. It uses assembler. It has a version 0.1.0, and dependencies. We don't have any dependencies. And actually, it produced a link to the manifest where we can see how many other sections we can have here and what type of variables, keys, values they accept. Addition, by the way, stands for the language edition. In our case, it's 2018. And package, it's just a package name. So sections are separated with these brackets. And in dependencies, we don't have anything. Yeah. And if we do with CRC, we see there's only a main rs. Let's just observe this using Emacs. One neat thing. With Emacs, we see that it made a git init, so it already has a git, and it produced a git ignore and the code itself. In CRC folder, we have this main rs file, which contains basically the same function to main function with a println. Println here is a macro that basically puts a new line in front of every message. Yeah, that's basically it. Let's close this, and to run the here's a couple of neat things with a cargo. If with a cargo we can call cargo build. This will compile the code, and as I told previously, exactly what was expecting this compiling hello world version blah 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 in this path. And it says it's dev version unoptimized plus debug info. So by default, if you call cargo build, it will produce like an optimized version with debug info. And if we call this ls again, we see there's another files created. First of all, this cargo log keeps particular versions of dependencies that we use. Here we don't have any dependency. So it says this file is automatically generated. It's not intended to be manually. So version, so package, blah blah blah. Basically, it says we're using only our current version, this package. So the program itself is a package. And if we would have some dependencies, these dependencies with a particular version would land here. And the target, if we go like target, we see it has a debug folder. This debug folder contains all interesting things that Rust compiler produce. Basically, I guess we don't care about all these folders. Examples. It doesn't have anything, I guess. Let's something. Where we're basically interested only in this hello world thing. So if we would just remove this and make call this one, yeah, it's an executable file. And again, this unoptimized. If we would want to, the book says, if we would want to compile for production, for release, this program would look like cargo build dash and here, here release. We actually can specify the target by ourselves. Release. And let's try verbose. I'm not sure if it works or not. Oh, it works. Oh, it says gives all the default settings and all these things. Cool. Yeah, in this case, we would have target and not only debug folder but also release one. And release one will be optimized for because in terms of hello world it doesn't matter, but this one would be optimized for general optimized. It will be faster and better performing in benchmarking and so on. This one thing, and let's say we want to delete what we compiled, we would call cargo clean, and it deletes this target folder. That's it. I mean, and it's just purges it. Let's say we program in, writing a program, and it's getting big, and compilation takes more time. And to make it faster, just to check if the code that we wrote statically correct, will it compile? Just like this. We can call cargo check, I guess. Yeah. And cargo check will check the code and make sure that it's compiling. And this command will be way faster than compiling itself, just doing the cargo build. And book says many rustaceans use this cargo check instead of cargo build. And next stop here would be cargo run, and as name says, it builds and runs. Basically, it runs, but builds before that. So this also would save time. So instead of making cargo build, and then of course, it works only if your program is runnable by itself. It's not dependent on some environment and so on. And I assume the majority of programs that written on Rust, they are more system programs, and they can be run in this case. And you can see it's compiling, and when it's finished, it just calls the target. I don't know if I'm just curious if it with release will work as well. Ah, yes. Okay, so it just runs that code that optimized. I'm not sure if it's any if it does make any sense, but a release version kind of was faster than unoptimized one, and the check for some reason was slower. But I guess it's for hello world, it doesn't make any sense. In case of if the code already compiled and the compiled executable are present there, it won't recompile this, and you will just have this as it is. Yeah, so that's it for the moment. I want to make this a small chunk. It's already took almost over 20 minutes, almost a half an hour, and I would like to make them shorter and more in the tempo, these videos, and I hope this way of going through this book tutorial was fun for you. For me, it was because I doing something and teaching myself in the same time, talking to the camera. It's kind of weird, but still, it's also fun. Um, I hope you like this and you learned some little information about how the cargo basic functionality of the Rust cargo works. And if you like this, consider liking this video and subscribing and hitting the bell so you get notifications about new things. And yeah, see you next time. I will try to do this more regularly and often because learning Rust it's fun. I like this language and I have a good feeling about how this tool can be used in my work or fun side projects. Thank you very much. See you. Bye bye.